So now in this lesson, we are going to compare two population proportions. So if you have two independent binomial experiments and you want to test the difference between two population proportions, then you can use two prop z-test. Now, in order to justify using the two prop z-test, we have to check that the sample size is big enough. So we're going to take the sample size from the first population times the p prime from the first population, multiply that together and make sure that that's greater than 5. And you have to do that for q as well. And then you need to do that for the second sample as well. If these four conditions hold true, then you can use the two prop z-test. Now, if you want to use the formula to find your test statistic, here's your test statistic formula. It's p prime 1 minus p prime 2 over, and then all under the square root, you're going to have p1 prime times q1 prime all over n1. And you're going to add that to p2 prime q2 prime all over n2. And that's all going in the denominator under the square root. The steps to the hypothesis test is the same. When you set it up, though, you have your left-tailed test, and that would be, when you have this case, your null hypothesis will be p1 minus p2 is equal to 0. The alternative hypothesis is going to be p1 minus p2 is less than 0. For right-tailed test, you're going to have it when you're looking at your right tail. Your null hypothesis is going to be p1 minus p2 is equal to 0. And the alternative hypothesis is that p1 minus p2 is greater than 0. And then for two-tailed, when we're looking at both sides of the graph, you're going to have that the null hypothesis is p1 minus p2, and that the alternative hypothesis is p1 minus p2 does not equal 0. Now, remember, there's different ways that you can write this alternative hypothesis. You could write the alternative hypothesis for left-tailed test as p1 is less than p2. If p1 minus p2 is negative, then p1 has got to be smaller than p2. Another way to write the right-tailed test is similarly, p1 would be greater than p2, because if p1 minus p2 is greater than 0, meaning it's positive, then p1 has got to be greater than p2. And then another way you can write the alternative hypothesis, if it's two-tailed, you can just state that p1 does not equal p2. They're different. Okay, let's go through the first example. It says that the McKean County Clerk wishes to improve voter registration. One method under consideration is to send reminders in the mail to all citizens in the county who are eligible to register. As part of a pilot study to determine if this method will actually improve voter registration, a random sample of 1,250 potential voters was taken. Then the sample was randomly divided into two groups. So group 1 had a sample size of 625, and group 2 also had a sample size of 625. In group 1, no reminders were sent, and in group 2, reminders were sent. And then the people who registered from group 1, that was a total of 295, and then in group 2, there was 350. So N1, our sample size, is going to be 625, and N2 is going to also be 625. The number of successes in group 1 was stated to be 295, and X2 was stated to be 350. All right, let's see. What else do we have here? It says, the county clerk claims that the proportion of people who registered was significantly greater in group 2. On the basis of this claim, the clerk recommends that the project be funded for the entire population of McKee County. We're going to use a 5% level of significance. And we're going to test the claim that the proportion of potential voters who registered was greater in group 2. Okay, so group 1 was the group that did not get a reminder. And group 2 did get a reminder. All right, we're testing proportions here. And we're doing this with two samples, two populations. They're definitely independent. When we set up our null and the alternative hypothesis, we're going to get P1 minus P2 is equal to 0 for the null. Now, for the alternative, we're looking to see if the people who registered to vote was greater in group 2. That means when we set up the alternative hypothesis, that when I subtract P1 minus P2, that should be less than 0 if we're assuming P2 is greater. And the other way that you can write it is P1 is less than P2, or you can write P2 is greater than P1. We're using a significance level of 5%, which is 0.05. Now, we're going to use 2-prop z-test, but we need to justify that the sample sizes are big enough. So we need to show that N1 times P1 prime is going to be greater than 5. N1 Q1 prime is greater than 5. And then the same thing for the second sample. Now, to get your proportion, because it doesn't directly give us the proportion in the problem, but we've got the number of successes and we've got the total and the sample. So to find my P1 prime, I would just take 295 over 625. And for the second sample, for P2 prime, I would get 350 out of 625. That would give me my proportions. Now, I'll let you check this on your own, but it does come out so that it works, and we can use 2-prop z-test. All right, now to find our test statistic, you can use the formula if you'd like. I'm going to use the calculator method. I'm going to put everything under 2-prop z-test. I'm going to put that in the calculator. I'm going to get that my test statistic is negative 3.11, and I'm going to get that my p-value is 0.000926. And we know that this is left-tailed because of the way that we set this up, what we're testing. We're looking to see if the difference is less than 0. So let's set up our rejection region. Left tail means we're going to have a rejection region on the left side. We want to find this cutoff point here so that there's 5% in this area under the graph. So I'm going to use inverse norm. Since we're using z's here, we're going to use inverse norm, and we're going to find with the percentile of 0.05 that this critical value here to create my cutoff point is going to be negative 1.645. Now, when I look at my test statistic is negative 3.11. That's less than our critical value of negative 1.645, so it's going to fall in that rejection region. So I'm going to say reject the null hypothesis for step 3. For step 4, we're going to use the p-value method. And we got in step 2, when we did this on the calculator, we got a p-value that was 0.000926. That is certainly less than my level of significance, which is 0.05. And when our p-value is less than our level of significance, we say reject the null hypothesis. Okay, so for my conclusion, I'm going to state that at the 0.05 level of significance, there is enough evidence to suggest that the proportion of voters who registered in group 2 was greater than group 1. So we are pretty confident that reminders helped that group to get registered. Okay, let's look at our second example, which is basically just an extension of the first example. In this example, we're going to look at the voter registration again, and this time we're going to use a sample size of 1,100, and then this is the way it's broken up. Group 1 was 500 potential voters, and there was no registration reminders sent, and 248 was the number of successes, the number of people who registered to vote. And then in group 2, we had 600 in that sample, and 332 registered to vote. Now we're going to test it at the 1% level of significance. So we're testing the same claim, but we're changing the sample size a little bit. We're lowering the sample size just a little bit, and we're lowering our level of significance a little bit, and we're going to see what happens. So for group 1, we have 500 potential voters, and then in group 2 we have 600 potential voters. The number of successes from group 1 was 248, and the number of successes from group 2 was 332. Now if we wanted to find our P1 prime, our proportion of successes from group 1, we would take 248 over 500, and the success proportion from group 2 was 332 out of 600. Now we would like to use 2-prop z-test. However, we need to make sure that we can use this. So let's set up our hypothesis, and then we'll check that in step 2. Our hypothesis for the null is going to be that P1 minus P2 is equal to 0. And then for the alternative, we're going to say P1 minus P2 is greater than 0 because we're looking to see if the group 2 registration proportion is bigger than P1, which would mean when I subtract them, whoops, I wrote that backwards. When I subtract them, it's going to be negative. All right, and then we're doing this at the 0.01 level of significance. Now in step 2, we want to use 2-prop z-test, but we want to make sure that the sample size is big enough because we lowered it a little bit. We knew the sample size from before in the previous example worked, but we lowered it a little bit. So let's check it again. We want to check that N1, P prime 1 is greater than 5, and we're going to do that with Q as well. And then the same thing for the second sample. I'm going to let you guys do that on your own, but I did check it. It does work. So we are going to use 2-prop z-test. This is going to be left-tailed again because we're checking to see if P1 minus P2 is less than 0. Now, when I put all the information on my calculator under 2-prop z-test, I'm going to get a test statistic of negative 1.896, and I'm going to get a p-value of 0.0289. All right, so let's go ahead and get into our rejection region method. We're looking to see what that cutoff point is for this left tail. What is my z critical? Now, because we're doing z's here, because we're doing proportions, we're doing the 1-prop z. So I'm going to use inverse norm to find my critical value, my cutoff point, so that this is 0.01. Right, our level of significance is 0.01. So I'm going to use the percentile 0.01 and I'm going to find my critical value. So my cutoff point for my z critical is going to be negative 2.33. When I look at my test statistic, that's going to be negative 1.896. So that's going to fall between 0 and negative 2.33. So that is not in the rejection region. So I would say here, do not reject the null hypothesis. So just by lowering the sample size a little bit and our level of significance, our result has changed. All right, now for part 4, we're going to do the p-value method. We got that our p-value was 0.0289. That is greater than 0.01, which is equal to our alpha. When our p-value is greater than our alpha, we say, do not reject the null hypothesis. So again, just by making that minor change, we see a different decision. And this is why researchers, when they're using hypothesis testing, really look at the level of significance in their sample size to decide how strict they want to be in their level of confidence. Okay, so we would say at the 0.01 level of significance. There is not enough evidence to suggest that the voter registration in group 2 is greater than group 1.